Hello and welcome back. Researchers were talking today about correlations, and this is correlations part two. So let's continue. So now let's talk a little bit about what correlation means. We can't say that level causes exam scores or temperature causes sales of ice cream from correlation alone, even though we might think that it's true. Having a correlation just tells us that two variables are related to one another. It doesn't tell us why. And I threw up some cartoons that talk about, why and how sometimes you may not know why. There are possible explanations for a correlation. It could be that one of the variables is causing the other, but we might have it backwards. So, does the ding and the light going on when we're on an airplane mean that, it's the light that's causing the turbulence, or is it the turbulence that's causing the captain to turn on the light? Um, or it could be that there's some third intervening variable that's influencing our variables, and that's what's called a spurious correlation, when there's something else that's actually influencing both of the variables that we're measuring. And we're just, happening to notice this byproduct type correlation. Or it could be that our sample isn't representing the population well and the correlation really doesn't exist. And that last one is what we addressed statistically with hypothesis testing. So, for correlations, we're typically testing our null hypothesis that there's no correlation between two variables, that they are not related. The research hypothesis is that there is a correlation between our two variables, that r, the correlation coefficient, lowercase r, is not equal to 0. And our question becomes, how confident are we that our correlation isn't 0? So whenever we take a sample, it's possible it's going to misrepresent the population, right? And we talked about this as um, we're ready to accept a certain chance of error and about a 1 in 20 chance. We're willing to live with that. Um, and so you can get a distribution of a sampling distribution of a correlation when you're sampling from a population where the true correlation is 0, and that can kind of give you a sense of what is likely and what's not likely. So recall that we can calculate the chance a statistic will occur given that the null is true. The p-value for the correlation is the probability that a correlation this extreme or more extreme will occur to sampling error when the null is true, or when the real correlation is 0. If we were calculating by hand or with Excel, we'd figure out critical values. We'd look up at a table. We'd Google. We'd look up degrees of freedom for a correlation. It's n minus 2, by the way. And with a sample size of 50, let's say, and an alpha of 0.05 as usual, the critical value is 0.73 and minus 0.273 and minus 0.273. So a correlation more extreme than these will lead us to reject the null. This means that with a sample size of 50 and a true correlation of 0, calculating correlations more extreme than plus or minus 0.273 happen by chance only 5% of the time. Okay. When we have a value more extreme than our critical values, we can conclude that this would be rare enough that we would reject our null. In practice, this means we conclude that the correlation isn't 0. And again, we're willing to be wrong 5% of the time. So let's look at our ice cream sample. right? Recall that this was um, sales of ice cream depending on the temperature. Okay, and we would look things up, look at the critical value, might look at software, look at a table, that kind of thing. Okay, but we're not looking at a table because we live in the 21st century. We're going to use an app. All right, so we're like most data sets. This data set happened to be in Excel, and yep, I have it here. Ice cream sales, a data file. And so if I want to get that into SPSS, first I gotta open my SPSS. Oh, where is it opening? Yes. There we go. It's opening. There we get our splash screen. Now, this is giving some choices of files and that kind of thing, but these are files that we've already opened, and I haven't opened the ice cream data set. And in fact, it's an Excel file, so what I need to do is I need to import it. So I'm going to go to File, Import Data, and they have a little option for importing an Excel file. And it's in my, yeah, there we go. Ice cream sales data file.xls. Open. Okay. And this is the dialog box where um, it's going to read the Excel file. So it's asking me, which worksheet to use and which range. And usually I just let it do what it's going to do. Usually it selects correctly. Um, it's and so I don't check or uncheck any of these boxes. But I do look in this box here, this preview box, um, and to see if it looks like it's right. And it does look like it's right. These temperatures look correct, like 14.2, 6.4, 16.4. Remember, this was in Celsius. And ice cream was ice cream sales, so that was $215, 325. And it guesses what data type we're using, and it's guessing that it's a continuous data. That's why you have a ruler next to temperature and a ruler next to ice cream. And it's actually correct. And so I'm going to hit OK. All right. And now it has pulled in the data and given an extreme number of zeros to my temperature. And this data set is called Untitled 2, which I don't like because that means it's not saved. I always want to save. I'm going to go to Save As. And this I'm going to call Ice Cream SPSS data file. I always make data file capitals because I'm usually looking for it late at night and I'm like, where's my data file? Oh no. Okay. And save. Okay, we got to do something about all those zeros. That's going to drive me nuts. Okay, so what I'm going to do is going to go, let's see, go window. I want to go to the variable view. Syntax, no. Oh, I know, there's a tab at the bottom. Oops. There's a tab here at the, did it again. Okay, anyway, I'm going to click on it. Variable view. Okay, let me bring it back down so you can see. All right, there we go. Variable view. So we have two variables, temperature and ice cream sales. Temperature, it's saying 15 decimals. No, thank you. I think 1 decimal is plenty. And then ice cream sales was in dollars. And I don't think there were any cents in terms of the sales. It was all round dollars. And these are both, I always like to check that the measurement type is correct, and it is. Scale is what SPSS calls um, continuous variables. Okay, so now, oh, let's open up a Word document. Okay. And what I'm going to start I'm going to start out with some kind of introductory sentence. We sold ice cream during the final days of the YMCA skate, skate summer camp. We make this asked the research question, does the amount of ice cream sold relate to the temperature? Okay. We measured temperature in Celsius, in degrees Celsius, and quantified the amount of ice cream sold by keeping track of how much profit we made each day. How much, I'm just going to say how much money. I don't know for sure if it was profit or not. Okay, how much money we made each day. And then now I'm going to give some descriptive statistics because we want to orient the reader of our research report by letting them know something about our data. First of all, missing, what is this? Oh, there's no missing values. That's good to know. But why did it give me that dialog box? Okay, cancel. I don't know what happened there. Okay. Oh, I must have clicked on one of those boxes. Let me hit save again because when there's a star next to on the top bar above the menu bar, when there's a star next to the name of the data set, it means that the most recent version has not been saved. Okay. So I want some descriptive statistics. First of all, how many days did we? Oh, okay, looks like it was 1, 2, 3, 4, 12 days worth of ice cream. We sold ice cream for 12 days. Now let's get some descriptive statistics. I'm going to go to analyze frequencies. I want frequencies for both. The statistics I want, I'm going to go straight for mean and standard deviation. Range is sometimes interesting also. Continue, but the mean and the standard deviation are most important for your result, for this class. Okay. Charts. I do want a chart. I want a histogram. I don't need the frequency table. Okay. All right. Mean. Okay. The mean of temperature. So got frequencies and it says the data set. And here are my statistics. the wait, let me look at that again. The mean temperature was 18.7 degrees and the mean ice cream sales was $402. The mean temperature was 18 degrees and it's 18 point something. Oh, 18.6 is closer to 19. So if I'm rounding, that should say 19. Was 19 degrees and the mean um, and we sold a mean of $402 worth of ice cream each day. Yep. Now I'm going to put the standard deviation in parentheses. Well, I don't, because I'm not really going to comment on it. 4.0 and 126.0. SDSD equals 4.0. $400. SD equals 0.0. That looks weird, that 126.004, because we'll do the cents there. Dollars and cents. Okay. The we examined the distribution of temperature and ice cream earnings sort of normal on temperature. Oh, also sort of normal on ice cream sales. The distribution was, yeah. I mean, there's some missing, there's kind of a gap here and also over here, kind of two gaps, but overall it looks mound shaped. And this looks pretty pointy, pretty peaky, pretty kurtotic, although those all mean the same things. But it's mound shaped, it's fairly symmetrical, not skewed here. Okay. Both were basically, both distributions were basically normal. I'm going to throw in histograms showed that. For your assignments for this class, go ahead and put the histograms and refer to them. So you would do like C figures 1 and 2 in your so that would go in your appendix or in your last section. Okay, so this gives us the background. We have an introductory part and then we have the descriptive statistics part. Okay, and now let's go back to our slides. Okay, yes, we're learning about correlations. So, but you know what I like? Before I actually do the math, remember, remember one of the biggest problems is if the relationship between the two are is actually curved, curvilinear rather than linear. So what we need to do before any correlation is we need to do a scatter plot. So let's go to back to SPSS. And now graphs. The easiest way to make graphs is actually to use what they call legacy dialogues. This is apparently in the past. I mean, you could make it, excuse me, you could make it using the chart builder, but that gives you a lot of choices. When you don't need a lot of choices, you just need to know how to do it. You just need to make a graph quickly. I would use legacy dialogues, and we're making a scatter plot. We're making a simple scatter plot. Okay. Now we need to define what goes on each of the axes. Okay, so simple scatter plot along, I want you to think about predictor and outcome. Okay? I mean, you could think about independent variable and dependent variable, but I find that thinking in terms of predictor and outcome makes it easier to know what goes on the x and y axis. Your predictor is always going to go on the x, and your outcome is always going to go on the y. Independent variable on the x, dependent variable on the y. Okay, that's just the standard way of doing things. Okay, so predictor, I'm predicting that the temperature is going to cause people to buy ice cream or not. So I moved temperature over to x-axis. I moved ice cream sales to y-axis. I'm not going to worry about the title. What is his options? Exclude places list-wise is exactly what I want to do. Okay, continue. The titles just allow you to label the axes. We're not going to worry about that for this demonstration. And then I'm going to hit OK. And let me show you what SPSS spits out. See, this is the graph that SPSS generated. Look at these dots. Does it look like there's a relationship between temperature and ice cream sales? Why, yes. In fact, it does look like there's a relationship. Does the relationship look linear? Yes, it does. I can imagine drawing a straight line there. So now I'm gonna, you know how you click on the graph and it makes a box around it? I'm clicking on it and can I right click? Ooh, I right clicked with my mouse and I'm gonna click on copy, and because this has to go on my report. And now I'm going to hit paste. There we go. It pasted my graph right in my report. We created a scatter plot showing the relationship between x and y, between temperature and ice cream sales. See figure 3. As can be, oh, you know what? Period. As can be seen in figure 3, the relationship is linear. Also, there appears to be a strong relationship between temperature and ice cream sales. We found that the correlation between the two variables was Let's find out what's this correlation. Got to go to our output. We need to go to analyze, correlate. Bivariate just means two variables. And our two variables are temperature and ice cream sales. Options. Nope. We don't need the statistics. We already figured that, found those out. We're going to exclude cases list-wise, always, always, always. We're using the Pearson correlation coefficient. Once one person figures something out, other people, oh, hey, we can use this for this, and we can use it for that, and we can use it for the other. And that's what Kendall and Spearman did. They found other situations where you could use this approach. And we do want to flag significant correlations. And we're going to hit OK. And that's how we get the output here. Oops. That's how we get the output that, uh, sorry. Okay. That's how we get this output. And it's also on your slides. All right. And let's go back to the slides. Okay, so I'm showing you how to do what I just did. Okay, so here's the output, right? I want you to imagine a line going diagonally through the output. Notice that what's on one side of the line matches what's on the other side. Okay, the output is a correlation matrix. Correlation matrices are either in the shape of a triangle or they're two triangles that mirror each other along the diagonal. Ice cream sales and temperature were strongly positively correlated. And then there's the correlation. The relationship was statistically significant. We're not going to say it was zero because the p-value can never get to zero, all the way down to zero. But we can say that it's less than 0.001. We reject the null hypothesis. Oh, and this is a really good paragraph. Let me copy that. Okay. Oh, I make a statement about the correlation. Okay. We found that ice cream sales and temperature were strongly positively correlated, and there's the statistic, the Pearson correlation coefficient, the R. R equals 0.96. The relationship was statistically significant. This doesn't need a dash. P less than 0.001. We reject the null hypothesis that the correlation in the population is zero. We conclude that when the temperature is high, ice cream sales also tend to be high. Okay, I put it in kind of normal people language in that last sentence, in the conclusion sentence. Okay. So that should help you see how I get from Excel file. I work with it in SPSS, and then I write out my report. Okay, so let's go back to our slides. Yes. Now, statistical significance, what does it mean? It does not mean that the correlation is strong. That's what R is telling us. It also doesn't mean that the correlation is important. That's what your knowledge of your field will tell us. It does mean that the correlation is likely to be non-zero in the population. So it's not just because of what happened on those 12 days, it was just by chance. Okay? It's that likely in the population of summer days, you're likely to sell more ice cream on days that are hotter. Okay, so there are a whole bunch of different types of correlation coefficients. Pearson's is just one. And it depends on the type of data, and that's where we get Spearman, and there's a phi, and there's all kinds. Okay, but basically, SPSS is just going to spit out a coefficient for you. You don't necessarily have to worry about it too much because it's making the mathematical adjustments. Where you do have to worry about it is in your report. If you have continuous data for both variables, you're going to be talking about Pearson's R. If you have one variable is continuous, the other one's is dichotomous, you're going to call it a point biserial correlation. If they're both dichotomous, you're going to call it phi. Okay. Do you say that phi or phi? And if either one of them is ordinal, you're going to convert them to ranks and you're going to report them as Spearman's row. But you're still using the same formula. Okay, and that's it. I added some stuff in the appendix just in case you happen to have extra time. I hope that was helpful, and I'll see you next time. Bye bye.